Okay, let's get started. Hi, I'm Trustin, the lead of Armeria project and the founder of Neti project. In this session, I will briefly introduce gRPC just in case you're not familiar with it, and then show what effort is needed to productionize your gRPC service step by step. And I'm gonna use Armeria in the examples, but I try to make sure that this session is educational enough, and you'll notice all the techniques I show here will be applicable to your favorite frameworks as well. However, as we move forward, you will also find very interesting features you never saw in other frameworks, so please stay with me. Now, let's get started. So what is gRPC? What does it mean? Have you ever heard about gRPC before? Could you raise your hands? Yeah, lots of people. So it's an RPC protocol created by Google. So maybe it stands for Google RPC? The answer is no. Actually, it's a recursive term, which stands for gRPC Remote Procedure Call. I don't know who, how, and why they named it this way, but I believe there's some interesting story about it. So anyways, gRPC is based on Google's deserialization format called protocol buffers. So you define your service and message schema in a .proto file. Here we define the package name be.devox and the simple devox service that fetches the list of sessions. Nothing fancy. Very straightforward, right? What's missing in this file is a definition of getSessionsRequest and getSessionsResponse message. Let's see what it looks like. In the same file, we define the request and the response message type and other required type like session. The number at the end of each field definition is the field ID, not the default value. That's why it's 1, 2, 3, 4. So this field ID is used for distinguishing one field from another so that renaming or reordering it doesn't break backward compatibility. And there's also repeated keyword that effectively makes the field a list. For example, getSessionsResponse can contain multiple sessions, and the session can contain multiple speakers. So this .proto file is then compiled by the protobuf compiler for code generation. Protobuf compiler actually doesn't know how to generate gRPC related code at all, so we specify some plugin. Depending on which gRPC variant we use, we specify a different plugin. So for example, for vanilla Java, we use the official gRPC Java plugin. And if your project is written in Kotlin, then you can use gRPC Kotlin plugin. And if you're using a reactive stack, then you can also use reactive gRPC plugin, which is an open source project from Salesforce. But in this talk, I'm gonna use the official gRPC Java plugin for simplicity. But you can choose whatever you want, really. Once the compilation is done, you will see some Java source files as shown on the right side of the slide. We have getSessionsRequest and response, and session for messages, and devox service impl base, and devox service stub for devox service we defined earlier. So now that we have generated classes, we can implement a gRPC service by extending a base class. So in our case, the base class is devox service impl base, which has getSessions method. We implement this method to fetch the list of sessions from somewhere, like for example, database, and fill them into the response object, and then pass it over to the observer to send a response to a client. What's interesting is that we do not return the result object, but we use some kind of callback called observer to send a response. It's basically because all the services in gRPC are asynchronous by default. And also, another interesting fact is that this onComplete call, this is because a gRPC protocol actually allows you to stream multiple response objects depending on how you define your service schema. But in our case, our call is a single request and single response call, so which is called unary RPC. So we just call onNext just once and then call onComplete. But how do you make it actually server request? We only implemented a service-based implementation. Using Armeria, it's mostly about wrapping the service implementation with an Armeria service called gRPC service, and adding it to server and then starting it up. Quite straightforward, right? And if you want, you can add multiple service implementations or even add non-gRPC services to the server, but I'm going to talk about it a little bit later because it introduces a few very interesting features. So now we have a gRPC server, but this is only half of the story because we're living in the world of microservices, right? It's very likely that we write another service that calls our gRPC service. So we need a client for that as well. Protobuf compiler generates various stub classes like Devux service blocking stub in this example. We're using a blocking stub for simplicity here, but there are also asynchronous version, or depending on what gRPC compiler plugin using, you will see some other stub implementations as well. But in this case, we're using blocking stub. So Armeria has a factory method called gRPC clients.newClient. So it does all the heavy lifting for performing the actual network I/O and all complex stuff. It's actually built on top of Netty. So all you need to do is to prepare a request object and then call the stub method to make an RPC call. And it's quite straightforward again, and it's even a little shorter than the official gRPC Java, which is good. Now, let's do a quick recap for what we have built so far. So we have a gRPC server and a client, and they send and receive a gRPC call via HTTP2, and they utilize Armeria as its networking stack. Nothing fancy, right? So at this point, you might start to wonder, like, what's the point of using Armeria? Armeria doesn't seem to add much at all. You know, you can do the exactly same thing with the official gRPC Java, right? It's a little bit more verbose, but it's not a big deal once you write it once. However, the story takes a turn as your service scales out. So what could we do when we have many server instances? How does a client distribute the load to them? And how does it find the list of all the servers? So you could consider using load balancers, but that's another story. But here we're gonna focus on client-side load balancing, okay? So for that, we need a service registry that provides the list of servers. And the client could fetch the list of the servers from the registry and distribute the load using some kind of strategy like a round robin or weighted round robin, for example. So how do we do that? So this kind of mechanism is called service discovery. And the simplest yet most popular form of service discovery is actually DNS. So if you query a domain name, it returns an IP address, right? But sometimes it's not just a single IP address, but it has multiple IP addresses. For example, some very large company's domain, like Microsoft.com, if you do a query, it will return at least 5 IP addresses. So if you want to distribute the load to Microsoft.com, you're going to have to do a DNS query and get the list of IP address and distribute the load to all of them. So in this example, we retrieve the list of server IP addresses from a DNS server by using Armeria's DNS address endpoint group. What it does is to automatically and periodically send DNS queries so that you can add or remove an IP address dynamically in your DNS server. For example, it could be Route 53 AWS DNS server or whatever DNS servers that supports dynamic updates. And all you need to do is to create an endpoint group and then specify it when creating a client instead of specifying the URL like we did before. But as we all know, a server can go down for various reasons. It could just break. This means we can't just distribute the load to all the servers, because otherwise that servers will get the request, which is something we don't really want, right? So we should make the request go to the healthy servers only. How do we do that? So we can remove the dead servers manually from the service registry, but it will be really nice if a client handles this sort of situation autonomously, right? An autonomous client could automatically stop distributing the load to dead servers, shutting down servers, or restarting servers. So if a client can do that autonomously, then it will reduce the operational burden quite a lot, right? So how do we do that? The most common technique for such scenario is to send periodic health check requests to each server and to remove the dead servers if there is a bad response from it. So by doing that, we can stop sending a request to a bad server as soon as we detect such a bad server. So in Armeria, we wrap an existing endpoint group. In our example, it was DNS address endpoint group. And we wrap it with health check endpoint group here. So in this example, a health check request will be periodically sent to internal/L7 check. Of course, the server needs a little bit of change for this too, because it has to handle the health check request. So we add a new service called health check service s/internal/L7 check. So problem solved? Really? Not really, actually. However, in reality, this health check request doesn't get the actual business logic involved, right? It just says okay. So it's possible that health check service returns okay, but the server is not actually very healthy. For example, the business logic like fetching something from database could take too much time, causing timeouts. In this case, a health check request will still return okay, but it's not actually okay. So in this case, it'd be better giving up quickly rather than waiting for too long until the timeout occurs. By doing this, the database and the customers will get the error response. The customer will get the error response quickly, and the database will not get too many requests that will time out anyway. So in overall, this is gonna be a better experience than getting nothing. Customer just staring at blank screen, right? That's not a good experience. So we just tell them, oh, we are under load, please wait. We could do something like that. So this technique is called circuit breakers. And it's something you should definitely consider in your production services. But first things first, what is a failed request anyway? Whether a request has failed or not often depends on the business logic. So we have to tell Armeria or your favorite framework about that. So in this example, we'll mark a request as failed when any exception is triggered or gRPC static code is not 0, which means not okay. So of course, there are many more criteria you can specify using the Fluent Build API, but I just try to keep things simple. So we defined what a failed request means. And the second thing is, the second piece of the configuration is about the sensitivity of the circuit breaker. So there are quite a few parameters that control this using the Fluent Builder API, but what you mostly care are the failure rate threshold and the minimum request threshold. So if you specify a very low value, the circuit breaker becomes too sensitive and it will be opened prematurely. But if you specify a very high value, it will never be triggered and there's no effect of using this. So you're going to have to choose the right value for your service, although we specify some, sensible default value. Now, we have circuit breaker and circuit breaker rule defined. We can add a circuit breaker client to the gRPC client we create earlier. So as you see in the example, we switched to the Fluent Builder API to specify a circuit breaker client. It's a decorator that literally decorates an existing client to modify the original behavior of the gRPC client. So a decorator in Armeria is core construct that's used for adding common functionalities. So as we move forward in this session, you'll see we add more and more decorators. But here, we first add a circuit breaker. Anyway, our gRPC client now has a circuit breaker, so it will automatically fail fast as soon as it detects there's something wrong at the business logic level, which is good. But there's also another failure scenario, which is not really related with business logic, but rather related with some environment. For example, there will always network issues. For example, some people might replace or upgrade network switches, routers, and sometimes the connection will be closed for unknown reason. In that case, we can just give up, but we could wait just a little bit and try again. Then it will most likely to succeed, right? We always saw that kind of situation very often. So this kind of intermittent transient failures, we could handle them more transparently, just like if we can automatically retry those failure situation. So here, this is the example of adding a retrying, automatic retrying functionality to Armeria. So here, we defined something similar to retry rule, and something similar to circuit breaker rule we defined in our circuit breaker pages. So we define what the failure means. So this is mostly about what is the retryable failures. So here we decided to call a failed exception, a failed request, a retryable request if it is failed because of an exception. That's instance of my retryable exception. And then we specify backup. Backup is used for how much time we should wait for until we make a retry request. So here we used exponential backup, which is very common in this kind of scenario. So as its name says, it's exponential. So it starts with 1 second, and after on the second attempt, retry attempt, the delay will become 2000 millisecond and then 4000 millisecond and so on. So now we specify the retry rule. We can create a retrying client, which is also a decorator. So we add another decorator to the client builder calls. So now our DevOps service blocking stuff is now retryable, automatically retrying, and also automatically fails fast when the backend has some kind of issue temporarily. So far, yeah, we applied circuit breaker and the retrying client, which is good, and we also did health check. So we applied all those client-side autonomy, so that the client automatically handles all kind of failure situations. But we still need to understand what's going on inside our server. So that's what we call observability. So we add metrics, and depending on certain metric value, we fire an alarm so that we can preactively handle that kind of situation to prevent any outages. So how could we do that? We should add metrics, right? So adding metric is about also in Armeria. It's a common functionality. So we add a metric collecting service to Armeria server. So this time we are adding a decorator to a server, not a client. So here we added metric collecting service and some kind of configuration, and then add it. Then automatically all these RPC calls will be measured. Its timing information, error code, all those stats will be collected into micrometer registry. Micrometer is a metric collection library built by Spring folks. So it's kind of default metric collection library in Spring. So it integrates as well, very well with Spring. Now, we collected the metrics, but how do we expose them? There are many ways to expose those metric numbers to some metric collecting system, but what's most common is Prometheus exposition format. So we add another service called Prometheus exposition service. By doing that, all the metrics we collected will be exposed at this endpoint called internal/metrics. And then you configure your Prometheus instance or to scrape this server so that the metrics are collected into some kind of metric storage, and then you can browse it in some other dashboard like Grafana, all the usual monitoring system stuff. And the second part of this example shows that we add a registry, Prometheus meter registries, .default registry. This is necessary because we are using micrometer, and micrometer is not only a Prometheus registry, but can also be any kind of registry for any metric collecting backend. So for example, it could be Datadog, or it could be some other metric collecting system, Dropwizard, whatever. So by default, it does not add any actual registry implementation. So we add it to the global registry so that Prometheus metric registry support is added. If you're using Spring, this is probably done automatically, so you don't really need to do that. Armeria already has Spring integration, works pretty well. And if you have some more room for, if you feel like you want to know more about your services, you can think about adding distributed tracing. This usually involves more effort than just adding decorator, because for collecting distributed traces, you have to set up some dedicated storage like Elasticsearch or maybe something else. And then you also need to set up the server to collect the spans received from all these microservices, and the amount of data might be quite huge depending on the number of calls and the number of services you're having. So you might not feel like doing it for now, but as the number of your services grow up, you will probably want to do this. So for doing that, there are many different solutions for this kind of job. One option is OpenTelemetry, which is using Java agent to inject some tracing bytecode into your code. That also works with Armeria, but in this example, I'm going to use Zipkin, which is a little bit less involving. So you set up some object called tracing, which contains all the configuration for sending distributed tracing information, and then you specify that when you create a client or a server, and then inject a decorator, tracing decorator, in this case Brave client or Brave service, into this decorator chain to enable distributed tracing. So on the server side, it's pretty much same, So now we have all the necessary pieces on the table. So the story so far is a little bit more engaging. So we have DNS as a service registry, and we have a bunch of decorators and endpoint groups to retrieve the list of endpoints and filter that servers and automatically retry failed requests, or preventing and adding circuit breaker to prevent the outages from spreading from one service to the other service. And on the server side, we also have metric collection and distributed tracing, stuff like that. So at this point, Armeria adds more. You'll see Armeria adds more value, which is not available in gRPC Java or any simple gRPC implementation. But even if we have all these goodies in Armeria, there are some people saying that gRPC actually does not really have a great developer experience. As great as REST API or some other well-known protocols. So some of the reasons for that is tooling. So when we deal with REST API, there are a bunch of tools: Swagger, OpenAPI, Postman, curl. It's very easy to call a certain REST API endpoint using GUI, or you can even use your favorite tools. There are so many tools, and you can even use Telnet or Netcat to send a request really quickly. But gRPC is basically HTTP2, which is binary, and gRPC is protocol buffer, which is also binary. So you cannot just open Telnet and try to send a quick debug request. That's not possible. And also, let's say you want to send a gRPC request using some kind of tools, you still need .protofile definition. Without that definition, it is not really easy to send those requests. There is also There are some ways to do that, but not all services, not all gRPC servers have that. So in Armeria, we provide a web-based GUI, which is called the documentation service. In this single-page application, we provide a complete list of services and service methods and message types available in a server, and provide, of course, some specifications for them. And you can also add some text, human-readable documentation like Java-like documentation in here, although it's not shown here. And what's more interesting about this is that it has a button on the right top side, debug. This is really useful. So it's more like a Postman or, very useful GUI-ish debug or calling invocation service available in, REST API world. In here, we specify a gRPC request as a JSON, and then you can submit it. Then it will automatically submit it to your gRPC server running locally or running in the same server, and then display the response as a JSON. And this is very, very convenient because you can always very easily try to send a request only if when you just know the IP address or address of the server and the path of the doc service. It's usually /docs, So let's say you have some gRPC server running in your cluster and you want to know what's going on in there, then you can just type its IP /docs, then this window, this UI pops up, and then you can browse the list of services and what they do, and you can even try to send a request to it. What's even more interesting is you can also generate a curl command from this, or you can just copy the browser location and share it with your colleague. For example, let's say you have a gRPC service running a little bit weirdly, probably because of a bug. Then you write some request that triggers some kind of that weird behavior and then submit. Then you'll see a bad result on the right side. And then you share the URL of that request with your colleague. Then he or she can easily reproduce the problem by themselves, which is much easier than describing the problem, abstractly or, old-fashioned way. So it adds some kind of social aspect to debugging, which is good. And another shortcoming of most gRPC stack is that it requires another HTTP port. So for example, let's say you already have an HTTP service, REST API service on port 8080, and you now want to add a gRPC service. Mostly because most gRPC server implementations requires a dedicated TCP/IP port. You have to assign another port. So for example, let's say for REST API you assigned 8080, and you must assign another port like 8081 for gRPC. Unnecessary. I think this is unnecessary implementation detail. So in Armeria, you don't have to do that. So you can share REST API, Tomcat services, all those different services. You can serve all of them in a single HTTP port. Because Armeria implements its own HTTP engine, which provides some level of abstraction. So this is really good because let's say you have a Spring Boot application and you want to add gRPC support, or you want to migrate from REST API to gRPC for some reason, or you can even consider, there are some old RPC protocols like Drift, and it's not very actively developed anymore, and you want to migrate from Drift to gRPC. To do that, you previously you had to launch two servers, one Drift server and another gRPC server. But with this architecture, you don't really have to do that because Drift server and gRPC server can all run in the same JVM instance, and network layer is unified by Armeria's HTTP engine. It also integrates some legacy technologies like Tomcat or Jetty, the serverless containers. So let's say you have some legacy application running on top of Tomcat and you want to switch to reactive stack. You can do that too. You can launch these two different style of services in the same JVM and let Armeria handle all the network requests. Then you can serve them all in the same port. And it also supports many different protocols from HTTP to proxy to SOCKS to even Unix domain sockets, just in case you have some kind of sidecar. And what surprises many people when they adopt gRPC, they realize that they need a sidecar, even when they really want to. For example, in gRPC, there's a variant called gRPC Web. The gRPC protocol uses HTTP trailers, but HTTP trailers cannot be sent from JavaScript to web application. It's some kind of limitation from a browser, so you cannot send a gRPC request. So there's a special specification called gRPC Web. So your gRPC server must support gRPC Web. Otherwise, your web browser application cannot send a gRPC request to your gRPC server. And if you look into Google's, Cloud API documentation, they provide all those REST API specification, but internally they are all protocol buffers, gRPC. They provide some kind of automatic transcoding mechanism, and they also define it in some standardized doc publicly. And to enable that, if you're using Go, it's relatively easy. But in Java, official gRPC Java does not support it. So you have to add some kind of sidecar or gateway, API gateway server to enable that. And you have to, add one more instance. This means you have to add one more server, and then you have to provide the same set of .protocol buffer file, .proto file. So you have some kind of maintenance burden or operational complexity here. But because we have built our stack by ourselves, we had more freedom to implement them into Armeria itself. So by default, gRPC Web is supported out of the box. So you can easily call your gRPC services from your browser, and you can easily enable HTTP JSON transcoding, just adding one builder method. So by doing this, you can use binary gRPC protocol internally for internal service-to-service communication, which is very efficient, fast. But when your customers are talking to you, you could enable HTTP JSON transcoding so that they can communicate with you using REST API. So this is a very convenient feature. So so far we talked about what gRPC is and how you usually write gRPC server and client, and how you add more production, how you add more features for you to make your service production ready, like adding more decorators or adding health checks and stuff like that. So that's pretty much what I have for you. So here's my final pitch. So Armeria supports gRPC very well. So if you have any plan to write a gRPC service, it might be a good choice for you. And of course, when productionizing any service, whether it's gRPC or not, but Armeria provides all those decorators and endpoint groups for easily productionizing your service. So you might want to consider that too. And as I said previously, it has its own HTTP engine, which is based on Netty, and it's very efficient and powerful. So it is capable of integrating many different technologies, from servlets, Tomcats, to reactive stacks, and Drift to gRPC, to whatever technology you might have imagined. It even integrates GraphQL, WebSocket, yeah, stuff like that. So you will probably like it. And we have a very good vibrant community. So just feel free to stop by and let us know what you think. And yeah, we'll be happy to help you with giving an Armeria a try. So please come to us. Thank you. Any questions? No questions. Okay. Thank you for coming to my session. Just in case if you have any questions, I will be waiting here. So just let me know. Thank you.